Hello, everyone. Welcome to episode number 2 of It Depends video series. The topic for this episode is data observability. This is a topic which we are hearing about a lot these days, but there's very little clarity as to what does it mean. There are a number of players, new products, companies that have come into this space, and it's getting difficult to understand what are the goals, what does it really mean to do data observability. So the attempt for this session is to clarify and provide you with a point of view of what is data observability. Today, we will talk about the background, the meaning, and introduce to you some key topics and leave you with the list of companies in this space. In future, we will look at what are these, how are these different companies, different products different, and how do you evaluate one product from another. But for now, let's dive straight into our agenda for today. The agenda today is an introduction of what exactly is the problem that we are facing and why we even need data observability. Then we will introduce this notion of data SLA, or service level agreement. Finally, it'll get us to explaining the history and the rationale behind data observability. And then I want to end with sample products. And as a bonus, who cares whether we have data observability or not? So that is the agenda. Let's dive straight into the introduction. So the premise is, and this, by the way, is also documented in a blog that accompanies this video. So if you are interested in reading that blog, please go to sanchmo.com. The issue that we are dealing with here is, or the way I portray this is that for the longest time now, for many years, we've had service level agreements, SLAs, for applications and infrastructure. We've got system reliability engineers, or SREs, that are constantly monitoring the applications, the infrastructure, and they're reporting on the uptime, the performance, and all of these things. But we've never had SLAs for data. Why is that? So first of all, we have to really understand that, applications don't change as often as data does. Sure, Netflix maybe, having multiple copies of their microservices change constantly, but those changes are tuning the application. They're not really changing the behavior or the business processes as much. But because the data changes quite frequently, so it's very hard to pin down and say this is the expected SLA of how accurate the data will be, how performant it will be. That's one problem. The second problem that we are also facing is that the number of source systems and the pipelines that we are building has become highly complex. I talk to banks and they tell me every day or at any given time, they are ingesting data from dozens, sometimes hundreds of data sources into their environment. On top of that, they have maybe 1,000 or more data pipelines that run every day. Something's going to break, and now it's very hard to tell what broke. So this is the reason why handling data is becoming a more complex problem as we get into more complicated or more architecture patterns. So if we were to have a data SLA, what would we be measuring and looking at? So I've listed 4 things here. Data quality is the most obvious one. We need data quality monitoring so we can tell, is this data accurate? Is this on time? How trustworthy is that data? And the whole idea is that we don't want the data scientist or the data analyst to be munging and preparing the data 80% of the time. We want them to know that you can trust this data and you can use it. It gets more interesting when we look at data behavior. Data behavior basically says the data may be accurate, but is it the right data? Has the data changed? Has COVID-19 caused the data to, the patterns to change, that the data itself may be correct, but the trends show the data should be at a certain level, but the actual values are different? Is that an anomaly, or is that to be expected? So understanding how that data behaves becomes the next key topic. Now, data privacy is something that we all know how important that is. With the advent of compliance regulations like the EU GDPR, CCPA in California, we need to understand what sensitive and private information is stored in all of our data silos, all the data sources and copies of data that we've been making over the years. If somebody invokes their right to be forgotten, well, how are we going to forget this person if we don't know where this person exists? So yes, you have MDM, master data management, and you have all of these products that do that. But the problem is that when we identify the sensitive or private data, we then need to protect it. We de-identify that data, send the data through the data pipeline. The data pipeline then joins that data with a number of other products, data coming from other products. What if we now have inadvertently re-identified that data? We need to be aware of that, and that comes through understanding the entire journey of that data. All of these are very tactical reasons of why we need to understand our data. Data ROI is a more strategic initiative. Data ROI basically says that we collect all this data. In fact, many companies almost never ever want to delete any data. So we are collecting all this data, but can we associate the data with the value it's creating for the business? Can we take the data and see how aligned is it to our business strategy? If we are going to scale up our data infrastructure, which most companies are scaling up as the demand goes up, is it cost efficient? What is the cost of scaling that data is a key insight that we want into our data. This is a reason why we need data observability. So let's look at data observability and try to break apart this space. So to understand this, we are going to dial back and look at what is observability. Observability is not a new concept. It's been around for a long time in the infrastructure space. It's only now that the term has become very prominent. But on the infrastructure side, we have been observing, and our focus has been on either performance or reliability. When you observe the data and you collect these metrics, that's when monitoring comes into the place. So monitoring actually takes that data that we have observed, and the job of monitoring is to visualize it, analyze that data, and if it finds that there are some things that need attention, then alert or notify the right people. So that's why a good monitoring system should have observability built into it. Observability, on the other hand, does not need monitoring. You can observe and write that data into maybe a machine learning model. Now, let's look at what is data quality monitoring. If we go back in time, we see that these vendors in the data integration space were creating these products to literally help their customers integrate data from multiple different data sources. In order to do that integration, they introduced data profiling. Once they started profiling the data, they realized that, oh, we can use this data profiling output and start applying it to data quality. But data quality monitoring still runs on rules. These are static rules, and there it doesn't really understand what are the external externalities of that data. So that takes us to data observability. The big difference is that in data observability, you're not just looking at the data itself. You are looking at the data's interactions or correlations with the entire ecosystem. For example, what was the compute infrastructure that was used to transform that data? Where did that data land, and what are the storage characteristics of where that data is? How is that data being consumed? What metadata is being created, and the lineage? So the idea is that if we move away from taking a very data-centric view into the pipeline view, then we can say that if one of my 1,000 data pipeline jobs broke last night, how can I understand where in the pipeline did it break? So data observability is observing how the data is going through this entire pipeline from ingestion or creation to consumption. So with that, let's look at what are the use cases, who cares whether data observability should be done or not. So this is a very interesting question. I ask this question to audience and I say, do you think it's a top-down problem or do you think it's a bottoms-up problem? So what do you think? The answer is it's both. Why do I say this? The CDO, which stands for Chief Data Officer, or the Chief Data and Analytics Officer, are very interested in observing the data to see what value is being created. The CIO and the CIO or the CTO, they are interested in understanding what is my cost of running the data infrastructure. Can I save cost by going into the cloud? Am I just sitting on decades of data that nobody cares that I can get rid of? So what is the cost benefit of that data? CISO, which stands for Chief Information Security Officer's job is to secure the data. If there is a breach, then what sensitive data was breached and who has access to that? How do I protect that data? The concerns of CISO. DPO is Data Privacy Officer. This is a role that became more important once the GDPR came into existence. The Data Privacy Officer's interest is in ensuring that any private data adheres to the compliance regulations and to be able to fulfill the request of the customers who want access to their information. So this is the data observability use cases that we see that are top-down. Bottoms up, data engineer is busy building data pipelines, something breaks, they need to understand very quickly where in the pipeline did that problem happen, so you can then go back and fix it. Data observability is one of the ways by which you can find out how that data breakage happened. Same thing for data scientists. Instead of spending 80% of their time munging and wrangling or preparing that data, is having that clear view into that data so they can start using the trusted data in their models rather than trying to do some detective work in understanding, is this data coming from the single source of truth? Exactly the same reasons for data analysts. So we want to end with this last slide. I have listed a few products here in alphabetical order. These are the products that you're hearing about quite a bit these days. All these products are very much in use these days. The only one that has been acquired is no longer on the market is OwlDQ, which Collibra acquired earlier this year. And in a future episode, we will go deeper into the space and we will talk about the pros and cons of these products. So for now, thank you very much for your time, and it's been a pleasure talking to you. Thank you.